Have you ever wondered how some treasure hunters pull amazing finds from places where other detectors just go haywire? You know, like an ancient coin on a saltwater beach, or a gold nugget in that iron-rich soil that makes most machines just scream with false signals? Well, the secret is a technology that doesn't try to shout over all that noise. Instead, it waits for the quiet. And then, it listens. So what's the trick? Let's dig in.
Man, it's such a frustrating feeling, right? You've got a great metal detector, you're on a promising spot, and all you're getting is this constant, annoying chatter of false signals. The hunt just feels like it's over before it even starts. But what if the problem isn't the treasure or your detector? What if it's the ground itself?
Think about it. In perfect ground, everything is easy. You get these nice, quiet, stable signals. A coin sounds like a coin, and a bottle cap sounds like a bottle cap. But in what we call mineralized ground, we're talking wet, saltwater beaches or the black sand you find in gold country, it's total chaos. The ground itself is basically conductive, creating this wall of ground noise that can completely hide the signal of a really good target.
And that, right there, is the mineralization problem. It is the #1 reason why so many hunts just don't pan out. The very soil you're trying to search is essentially screaming at your detector, drowning out that faint little whisper of a gold ring or an old coin that's buried just inches below your feet.
So, this leads to a really cool idea. Instead of trying to fight the noise or filter it out, what if there was a way to just let the noise die out on its own and then listen in the silence that's left behind? It's a totally different way of thinking, and, well, it changes the entire game.
And that game-changing approach has a name: Pulse Induction, or PI for short. This is the tech that absolutely thrives in the exact places where regular detectors just give up.
So what's the difference? Well, most detectors you see are VLF, which stands for very low frequency. They send a continuous, humming wave into the ground. PI detectors, on the other hand, don't hum. They send out these short, super powerful bursts of energy. And that tiny difference is everything. It's what lets a PI machine excel in that nasty mineralized soil and saltwater and lets it punch way deeper than most VLF detectors can dream of.
All right, so how does this whole pulse and listen thing actually work? Let's break it down step by step. It's actually pretty straightforward. Okay, first, the detector doesn't hum, it shouts. A really powerful pulse of current flashes through the coil, creating this strong magnetic field that completely floods the ground, but only for a split second. And this graph here gives you a perfect idea of what that shout looks like. It shows just how intense and crazy fast this pulse is. Look here, the current jumps up almost instantly, holds for just a few microseconds, that's millionths of a second, and then poof, it's gone. This is not a gentle wave, it's a powerful jolt of energy.
Then, just as fast as it appeared, the current gets cut off. And when that happens, that big magnetic field it created instantly and rapidly collapses in on itself. This collapse is the real trigger for the whole process.
You see, when that field collapses, it forces any metal object nearby to create its own tiny little electrical currents. We call them eddy currents. It's kind of like dropping a stone in a pond. The collapsing field is the stone, and the eddy currents are the ripples that spread out from any metal target in the water. These little currents make the target generate its own faint magnetic field, like a tiny magnetic echo.
And here is the secret sauce. In that tiny silent gap, after the big pulse has died, but before the next one starts, the detector's coil flips its job. It stops being a transmitter and becomes a receiver. It stops shouting and starts listening for that faint magnetic echo coming back from the target itself.
So this whole transmit then listen process, that is the secret to why PI is so good. It's how it manages to just completely ignore all that problem ground noise.
And don't just take my word for it. Research like this points it out perfectly. The main strength of pulse induction is its almost magical ability to tell the difference between a real target and all those annoying false signals that the soil creates.
Now check this out, because this graph shows you the secrets. Look at that yellow line. That's the signal from the soil. See how it decays and just vanishes almost instantly? But look at the other lines, the pink, blue, and cyan. Those are metal targets. Their signals decay much, much more slowly. They linger. And that little gap, that's the PI detector's magic window.
So to put it really simply, the PI detector is just patient. It sends its powerful pulse, and then it just waits a few microseconds for that noisy, fast-fading signal from the ground to disappear completely.
And only then, in that perfect quiet, does it start listening for the signal that's still lingering from the actual treasure. And modern PI systems are even smarter than that. They don't just hear a signal, they analyze it. Imagine taking a little snapshot of the target's signal at different points in time as it's fading away. By comparing these snapshots, the detector can actually map out the unique shape of that target's decay curve.
This analysis lets the detector figure out the target's time constant. You should think of it like a magnetic fingerprint. Every metal object has its own unique time constant based on its size, shape, and what it's made of. By measuring this fingerprint, a really advanced PI detector can start to tell the difference between, say, a valuable gold ring and a worthless piece of junk foil.
Okay, so that's the science. It's pretty cool, right? But what does all this sophisticated tech actually do for you in the real world? Let's look at what modern PI detectors bring to the table. Well, the benefits are huge. You get incredible depth, and you get to totally ignore saltwater and bad soil, which makes these things amazing for gold prospecting. You also get way fewer false alarms, so you spend more time digging treasure and less time digging up trash. They're so sensitive, they can even find targets with just a tiny bit of metal in them.
And when I say the depth is incredible, I'm not kidding. Some high-power industrial-grade PEI systems can potentially find large metal objects, like a buried car or a treasure chest, up to 8 meters deep. That's over 26 feet down.
So who's relying on this kind of power? Well, pretty much everyone, from gold prospectors and serious beachcombers to archaeologists digging in really tough sites. But its use goes way beyond hobbies. Military and humanitarian teams depend on PI technology for one of the most important jobs on the planet.
And that job is clearing landmines and unexploded bombs. In soil that's just littered with metal shrapnel from conflict, a PI detector's ability to ignore all that clutter and pinpoint the actual threat, well, that's not just an advantage. That's a life-saving necessity.
So in the end, pulse induction is built on this really simple but powerful idea that the most important signals aren't always heard by shouting louder, but by waiting for the noise to fade and then listening in the quiet. It's a technology that helps us find lost history and helps protect future lives. And it kind of makes you wonder, what else is out there just waiting to be found in the silence?